This is a brief presentation from Group 7 on the role of IT in the production of dimethyl from natural gas. We'll start with the what dimethyl is and its uses. Let's begin. It's a versatile clean burning fuel, often seen as a potential alternative to traditional fossil fuels. Chemically, it's an isomer of ethanol, but unlike ethanol, dimethyl is gaseous at room temperature. And what makes it really attractive is how it is produced, especially from natural gas, which is cheaper and has lower carbon emissions than coal. In the real world, you will find dimethyl being used as a substance for LPG, a propellant in spray cans, and as a feedstock in making other chemicals. So it is both energy and industrial relevance. And in the process diagram, you can see that we have the steam reforming reactor. And what this is that it's in three step. It's a three-step conversion which starts from the natural gas which undergoes the steam reforming or partial oxidation to create the syngas. That's mainly hydrogen and carbon monoxide. This syngas is then categorically converted into methanol. Finally, we remove water from the methanol through a dehydration reaction to form DME. Each step is critical, so if the syngas ratios aren't right or the dehydration is incomplete, the yield drops, and the process also involves separation units to remove water and recycle reacted, unreacted gases to maximize efficiency. So let's look at the layout of units on the site. Okay, so beyond the reactors and converters, the site is fully equipped to function like a small industrial city. We have a control room for monitoring operations, a lab for quality control and analysis, and office for administrative functions. Security units are in place to ensure both personal and process safety. Then there are utility units like water, air, and power, which support the chemical processes. Efficient loading and storage systems are also essential to safely handling the raw materials and the final DME products. And moving on to the hardware part of the plant. Yes, so for the plant to run reliably, hardware is critical. We use sensors and thermocouples to monitor temperature, pressure, and flow in real time. Gas analyzers help us detect leaks or impurities, ensuring safety and compliance. So the operators view all this information through HMIs, that's human machine interfaces, which show process conditions using graphs, alarms, and indicators. So behind the scenes, PLCs, which is programmable logic controllers, run the automated form of all this, and they execute commands, collect data, and maintain stability across the system. So moving on to the software part of the plant, which is software is the brain that complements the hardware. SCADA, and SCADA are system control and supervise the plant in real time. They are like the nervous system of the operation. We also use modeling tools to simulate the process under different scenarios, which helps with troubleshooting and optimization. So in lab like LIMS, software tracks samples and ensures there's quality of products, while ERP software, While ERP software oversees the business side, inventory, scheduling, and accounting. And let's not forget about cybersecurity and maintenance tools that ensure long term reliability and data protection. Moving on to network connectivity and topology. All these equipments and software needs to communicate. That's where our network architecture comes in. We use a combination of LAN and VPN. So the LAN is a local and virtual private networks. So to ensure secure